The mystery of black holes. Welcome to iNest Facts, where science meets imagination and technology shapes tomorrow. From quantum computing to space exploration, we uncover the facts that power the future. So sit back, stay curious, and let's explore the wonders of innovation together. Subscribe now. The universe is filled with awe-inspiring wonders, but none are as weird or as mysterious as black holes. Objects so powerful that nothing, not even light, can escape once it crosses their boundary. But what exactly are black holes? How are they discovered? And what are the new discoveries challenging everything we thought we knew? In this video, we'll journey through the birth, the strange behavior, and the still unsolved mysteries of black holes. 1. What is a black hole and how they form? Black holes are regions in space where gravity is so strong that nothing, not matter, not light, can escape once it crosses a boundary called the event horizon. The concept arises naturally from Einstein's general relativity. If enough mass collapses into a small enough volume, you get enormous curvature of space-time. Formation. Stellar black holes. When a very massive star, at least 10, 20 times the mass of our Sun, exhausts its nuclear fuel, its outward pressure from fusion drops. Gravity wins, and the star collapses in a supernova explosion. The core compresses into a singularity, a point of infinite density, surrounded by an event horizon. Supermassive black holes, found at the centers of galaxies, million to billions of solar masses. How they grow is still debated. Recent observations, e.g. by Hubble, Spitzer, Chandra, and especially James Webb Space Telescope, suggest some supermassive black holes formed surprisingly early in the universe's history. 2. Key evidence and discovery history. Carl Schwarzschild, 1916, provided the first non-rotating black hole solution to Einstein's field equations. This gave us the idea of how a black hole can mathematically exist. The phrase black hole was popularized by physicist John Wheeler in 1968, though earlier ideas existed. Observational evidence came later. The detection of Cygnus X-1, a stellar black hole pulling matter off a companion star. The motion of stars near galactic centers, like Sagittarius A** in our Milky Way, showed something massive but invisible tugging on them. 3. The first image and event horizon observations. In April 2019, the Event Horizon Telescope, EHT, collaboration released the first ever image of a black hole, the supermassive black hole in the galaxy M87. It showed a bright ring around a dark center, a shadow caused by light being bent by the hole. This was a major milestone. More recently, in 2022, the Milky Way's own central black hole, Sagittarius A** SGR A**, was imaged with improved resolution. Scientists were able to confirm its shadow ring, consistent with predictions from general relativity. 4. Strange phenomena, gravitational waves, and quasi-periodic oscillations. Gravitational waves. In 2015, LIGO, Laser Interferometer Gravitational Wave Observatory, detected gravitational waves from the merger of two black holes, masses 36 and 29 solar masses, which then collapsed into a new black hole. It confirmed Einstein's predictions in a dramatic way. Quasi-periodic oscillations, QPO X-ray flickering in certain black holes. The frequency of flickers changes over time. This is tied to how matter orbits, spirals in, and may be related to how spinning black holes twist spacetime. These observations help test general relativity in extreme environments. 5. Hawking radiation and information paradox. In 1974, Stephen Hawking proposed that black holes are not completely black. Through quantum effects near the event horizon, black holes emit what's called Hawking radiation, slowly losing mass over eons. For large black holes, this radiation is extremely faint. This leads to what's called the information paradox. According to quantum mechanics, information about matter that falls in must be preserved. But if a black hole evaporates fully, does that information disappear? Physicists have been debating this for decades. Some new theories, including those involving quantum gravity, try to resolve it. 6. new mysteries and recent surprising discoveries. Black hole growing faster than theory. Astronomers found a black hole, RAX J0320-35, in the early universe growing at 2.4 times the Eddington limit, more rapidly than thought possible. How could it accumulate so much mass so quickly? Supermassive black holes forming early. Some are found just a few 100 million years after the Big Bang. This raises questions. Did they start from large seeds, huge gas cloud collapse, rather than from small stellar black holes merging? Observations support both models, but recent ones favor direct collapse in certain cases. 7. Spaghettification and what it means. If you fall into a black hole, feet first, the difference in gravitational pull between your feet and your head becomes enormous. This stretches you out in a process called spaghettification. Eventually, you cross the event horizon. Beyond that, physics breaks down in our understanding. 8. Primordial black holes and white holes theories. Primordial black holes, hypothetical black holes formed in the early universe from density fluctuations shortly after the Big Bang, not from stars. If they exist, they might explain dark matter or seeds for supermassive black holes. White holes, theoretical opposites of black holes. Objects that spit out matter, but nothing can enter them. Some quantum gravity theories propose that a black hole might tunnel/transform into a white hole over extremely long times, possibly resolving the information paradox. 9. Why black holes still mystify us. What is inside the singularity? We can't observe inside. Physics as we know it breaks down at infinite density. Do black holes lose information? How quantum mechanics and general relativity are reconciled in extreme conditions is still unknown. How exactly do supermassive black holes grow so fast, so early? Can we ever harness or use black holes for energy or for space exploration? In closing, black holes are among the most mysterious and fascinating objects in the universe. From theoretical predictions to direct imaging, from gravitational waves to paradoxes that puzzle physicists, our understanding has grown enormously, yet many questions remain. One thing is certain, every new discovery about black holes tells us not just about those invisible giants, but about the nature of space, time, and reality itself. Thanks for watching iNest Facts, your daily source for mind-blowing science and tech discoveries. Don't forget to like, subscribe, and hit the bell icon, because curiosity never stops evolving. Until next time, stay inspired, stay curious, and keep exploring the power of knowledge.